This is a project done by Singapore Polytechnic students. Hello everyone. Today, me and my group will be discussing about the engine cooling system. So, before I start my topic, these are the names of me and my group members. First of all is me, Suraj, and then there's Junhao, Ijin, and Taufik.
For our contents, we will be covering introduction, function, working principle, components, latest R&D, and suggested improvements. Introduction. An engine has an important role to play in aircraft during flight. What differentiates a good aircraft from a bad one is definitely an engine's performance. I mean, yes, we all know the basic structure and its aerodynamics are important as well, but they are not probably as important as the engine. Now moving on to our next point, we will be discussing about the cooling system. The cooling system is an essential part of the engine as it helps to keep the engine in proper working conditions. Excessive heat is undesirable in any internal combustion engine. We could probably break it down into two main reasons why the cooling system is so essential. Reason 1. The high temperature might also harm the engine and weaken it, thus shortening its lifespan. Reason 2. The high temperature will also change the properties of the lubrication, thus rendering the lubrication system useless. Functions. The function of an engine cooling system is to prevent the engine from overheating. The burning fuel within the cylinders produces intense heat. Although most of it is expelled through the exhaust system, there is still some remaining heat that needs to be removed to prevent the engine from overheating. Otherwise, the extremely high engine temperatures can cause undesirable consequences such as loss of power, excessive oil consumption, detonation, and even serious engine damage. On most occasions, the internal oil cooling system is sufficient to sustain the aircraft engine at its optimum temperature, but an additional method of cooling is necessary for the engine's external surface. Most small airplanes are air-cooled, although some are liquid-cooled. Now I will be talking about the working principles of the turbine engine cooling system. The turbine engine cooling systems uses variable inlet guide vanes. This variable inlet guide vanes has two purposes. First one, it is used to manage the airflow to prevent compressors stalling, and the second one is to cool the turbine's stationary vanes. As turbine blades and vanes are exposed to the highest temperatures in engines, the vanes must be made of creep-resistant materials and they must be able to withstand the heat. There are a couple of ways for cooling. Methods of cooling. Firstly, we have impingement cooling, also known as convection cooling. It is used only on certain parts of the blades. Secondly, flume cooling. This works by pumping cool air out of the blade through the small holes. Then lastly, we have transpiration cooling. It is similar to flume cooling, but rather than air being pumped through small holes, air is leaked through a porous shell. This cooling is effective at high temperatures as it cools the blade uniformly. As heat is the source of energy that gets the turbine working, reducing the temperature too drastically also means a drop of efficiency to the engine. So when designing an engine, there should be a compromise between the cooling and efficiency. Components. There are many components involved in the cooling of the aircraft engine. However, the engine cooling systems can be mainly divided into two types: air-cooled and liquid-cooled. In air-cooled engine, there are thin metal fins that help to project the heat from the outer surface of the engine walls and the head of the engine cylinders. When air flows through the engine and into the fins, it helps to cool the cylinders by absorbing the heat and carrying the heat into the atmosphere. Deflector baffles help to direct the airflow to produce optimum cooling effect. Those baffles are usually made from aluminum sheets. The engine's operating temperature can be controlled by the means of movable cowl flaps, which are located at the engine cowling. The cowl flaps are operated manually by either a switch that controls an actuating motor or a thermostatically controlled actuator. Liquid-cooled engine. Liquid-cooled engines consist of liquid passages around the cylinders and other parts of the engines that may require cooling. A liquid cooling system can consist of a radiator by which the liquid is cooled, a thermostatic element to monitor the amount of cooling applied to the liquid used, a pump to circulate the liquid around the system, and the necessary pipes and hoses used to connect the system together. A relief valve may be required if the system is sealed to prevent the excessive pressure within the system. The coolant used most commonly would be ethylene glycol and water, as it has a high boiling point and a low freezing point, which makes it a very good coolant. Latest research and development. Rolls-Royce has invested a lot of money to research ways to improve their engine cooling system, as they feel that it is essential in the performance of an engine. Computation fluid dynamics, also known as CFD, is used to provide gas temperature profiles and component wall heat transfer coefficients, and this is used in conjunction with finite element analysis (FEA) to predict metal temperatures accurately. Rolls-Royce and university research provides understanding, correlations, and validation data for novel cooling techniques. The increased demand for every greater engine efficiency places increased focus on advanced material systems capable of withstanding elevated temperatures and mechanical loads. Single crystal nickel superalloys have provided the basis for recent material developments for turbine components. Successive generations of single crystal alloys have been developed with continuously improving temperature capability, allied to high resistance to mechanical and chemical degradation. Latest research and development. Ceramic matrix composites (CMC) is being developed for various static applications with the aim of getting higher temperature capability and for reducing cooling requirements and weight. Rolls-Royce has over 20 years of experience in CMC technology and is currently investigating two types: oxide and oxide alumina and silicon carbide. Surface engineering plays an increasingly significant role in modern jet engines, providing improvements in component life environmental performance, and wear characteristics. Tribomet abrasive coatings are used on rotating seal fins to provide protection against wear and prevent thermally induced cracking. Environmental coatings are applied to many turbine gas pump components to provide increased resistance against oxidation and sulfidation attack, allowing extended service lives at elevated gas temperatures. Thermal barrier coatings allow increased turbine gas temperatures, thereby improving thermodynamic performance without the penalty imposed by increasing cooling air. Thermal barrier coatings enable turbine gas temperatures to be increased without the need to penalize increasing in cooling air consumption. Suggested improvements. Coolant flow rate. Increasing the coolant flow rate within the allowable limits will improve heat transfer and cooling performance. If the coolant flow rate is restricted or reduced, it may hurt the engine's cooling system's performance. Airflow. Improving the airflow through the radiator core will help to cool the engine more efficiently, as more heat can be dissipated through the increased volume of air. Factors that slow or block the airflow, either before or after the radiator, will hurt the cooling performance of the engine. Radiator surface area. Increasing the surface area of the radiator by making the radiator larger will help to increase cooling. Relocating other heat exchangers can help to expose more radiator surface area. That helps to increase cooling as more area of the radiator is exposed to the ambient cooling air. Fin count. Increasing the fin count may help to dissipate more heat into the atmosphere. However, it may not always be the case. Increasing the count to above 16 fins per inch will almost always affect the cooling performance of the engine. Climate and coolant used. For the best heat transfer performance in warm climates, use water as a coolant with an additive, which provides a corrosion inhibitor and water pump lubricant. In winter climates, a 50-50 water to ethylene glycol coolant is used, which includes corrosion inhibitors and pump lubricant.